everything. Today our class, it's a revision class for secondary student. You are the HSC batch 2020. Our revision class is going on. Today our revision class regarding chapter 9. That is first paper, biology first paper, chapter 9, plant physiology. You have some query about my last class. What about the total process of ETS, that is electron transport system? You know, presently it is present in our textbook, that is ETC. The previous class, class 9-10, we have called it, that is electron transport system, but now they mention it electron transport chain, ETC. So what about the chain? You first need to know why it is need to discuss. ETC is a very important term. You know, it's the last stage of aerobic respiration. What respiration? Aerobic respiration. And chapter 9, that is plant physiology. You know, the first most significant physiological process described in your chapter 9, that is called mineral nutrients absorption. Then second, that is process description of transpiration process. The third one is photosynthesis, and the last one is respiration. And we have just the last process, discuss the last process, and the last process, you know, respiration. Respiration, two type of respiration. One is aerobic and another is anaerobic respiration. Anaerobic respiration last, but the first process, aerobic respiration, you know, aerobic respiration held in where? The total aerobic respiration here, that is held in mitochondria, some part held in mitochondria and some part held in cytoplasm. And in aerobic respiration, air is necessary because higher plants and animals can't survive without air, that is free oxygen. They are tolerant oxygen. So aerobic respiration, the first process, both respiration, aerobic and anaerobic respiration, both respiration first terms is glycolysis. You know what is glycolysis? Produce 2 pyruvic acid from 1 molecule of glucose. Produce 2 pyruvic acid, that is 2 molecule pyruvic acid formed from 1 molecule of glucose. That is, after burning 1 molecule of glucose, it's formed 2 pyruvic acid. That process is called glycolysis. After that 2 pyruvic acid, it's converted into 2-acetyl-CoA. You know, that is class 9 and 10, the aerobic respiration have 4 parts. That is, first one is glycolysis, second one is formation of acetyl-CoA, third one is Krebs, and last one is ETC or ETS. But in class 12 or 11 class, intermediate book, you look, it is, they mention 3 steps. They are not mentioned here acetyl-CoA. Why, sir? Because acetyl-CoA not is the single process. It's a joint process attached with the Krebs cycle. And after completing Krebs cycle, the last process is electron transport system. Where from electron and how electron transport system is called? That is the total process of a plant physiological process. Electrons produced from where? You know, respiration process fully depends on photosynthesis. Because plant produces food first by using photosynthesis process, and after producing, that is food, this food needs to use for plant different type of physical activities, that is physiological process. Plant need use kinetic energy, and kinetic energy supplied from the potential energy collected by the photosynthesis process. And in photosynthesis process, you know, that is glucose is produced. My dear student, look attention please. In photosynthesis process, glucose is produced, that is the main product. Photosynthesis main product is glucose. So we use that same glucose for respiration, because respiration required glucose and it produces ATP. That is the kinetic energy. What is the full form of ATP? Adenosine triphosphate. So adenosine triphosphate, it is processed or it is produced by adenosine diphosphate and 1 molecule of inorganic phosphate. This is the photophosphorylation process. Okay, but after producing this ATP, some ATP already used in the photosynthesis. But continuous ATP is produced by the respiration process. Photosynthesis process, the light phases, you see some ATP is produced and some ATP is used, but respiration is a whole process that is fully produce ATP, and the ATP producing the total capacity from one glucose, that is 38 ATP. And 38 ATP produced from how molecule of glucose? One molecule of glucose. But the first two states, glycolysis and acetyl-CoA including Krebs, some reduced, that is NADPH2 and FADH2 produce NADPH2 or NADH2. On the other hand, FADH2 or FAD, that is FAD or FADH2, NADH2 or NADPH2 is produced from the previous 2 or 3 processes. That is, one is glycolysis, 2 NADPH2 produced, and acetyl-CoA 1 NADH2 is produced, and the last Krebs process, there is 3 molecule of NADH2 also produced, and after that 1 FADH2 also produced in the previous, that is Krebs cycle. But after the completing of Krebs cycle, what will happen, sir? The last significant process you mentioned here, that is called, what is that? ETC or ETS, that is ETS or ETC. So we need to know why ETC and AF, that is electron transport chain, ETC is required. From that NADH2 and FADH2, how many ATP is produced? Because you see, in glycolysis some ATP directly produced. So you can count how many ATP produced from glucose or glycolysis. It is easy to count. And some ATP or GTP is produced in the Krebs cycle. You just commonly see, yes sir, 2 or 1. But you need to know how many ATP is equivalent to a NADH2. How many ATP is equivalent to FADH2. And that is the main necessary to know the electron transport chain. So I just first draw electron transport chain. So you will do 2 ATP. So this electron transport chain, why electron and why, how transport and what is the chain? You see, this is a chain like structure. So from 1 NADH2 loop, this is reduced NADH2. From 1 NADH2, a reduced NADH2 converted to non-reduced NAD. So 2 electron is created, and these 2 electron convert by FADH2, and FADH2 also reduced. It is converted into FAD, and FAD converted into FADH2. FADH2 converted into FAD. Here also 2 electron comes, and coenzyme Q. What is coenzyme Q? Coenzyme Q is another vector, electron transporter from reduced coenzyme to, that is coenzyme Q, that is called ubiquinone. This is a vector, and using this coenzyme Q and QH2, this is also reduced and non-reduced, and that is ferric, ferrous and ferric. Look, 2 plus and 3 plus. Cytochrome B, C, A. What about the finalization? From 1 NADH2, 3 ATP, how you find? That is 1 ATP from NADH2, 1 molecule of NADH2 converted to NAD. That's why ADP and IP, inorganic phosphate, they produce 1 ATP. Then finally they produce another ATP and another ATP. From 1 NADH2, 1, 2, 3 ATP. That's why here 1 NADH2 equal to 3 ATP. But FADH2, you not find this ATP because this is outside the FADH2. FADH2, that is reduced from here. That's why it's count 1 and 2 ATP, that is 1 FADP and 2 ATP. But how? Why? What is the way for the electron transportation? You know, from 2 electron, it is start from here. You know, the arrow, it is connected to here. Electron comes here, and it is connected to this QH2. Coenzyme QH2, it is reduced, and electron come here, and it's flowing to the AFE, ferrous. and it is reduced, and these ferrous, this throw to the ferrous, these ferrous and these ferrous throw to it, this ferrous throw it to that ferrous, and that ferrous sending the two electron from the outside to the inside. That's why electron gradually lost his power and produced 1, 2, 3 ATP. If you count from NADH2, that is 1 ATP, 2 ATP, 3 ATP, but if you count from FADH2, this ATP is uncounted because it is started from here, that's why it produced 2 ATP. And finally the electron is received by the oxygen, because this is the last part of aerobic respiration. In aerobic respiration, oxygen presence is mandatory, and that's why it is another, somebody said this is called oxidative phosphorylation. The another name of ETC is called oxidative phosphorylation. You know, in my previous class I told you ATP producing reaction is called phosphorylation. But in photosynthesis we call it using light produce ATP is called photophosphorylation. But here no light is present because it is the incident in the respiration process, and ATP producing by the presence of oxygen. That's why it is called oxidative phosphorylation. So the another name of ETC is oxidative phosphorylation. Phosphorylation. So thank you, my dear students. This is the total description of ETC. Thank you.